Hi folks, we're going to take a look at number 9 from the Unit 6 assignment. So here they gave us this function which represents the cost, the average cost for a ticket with respect to the number of years since 1995. Okay, so here T doesn't represent the actual year, it represents the number of years starting at 1995, and then C is the average ticket price. All right, so the first question they ask us is, what was the average price in 1995? All right, so now we got to ask ourselves, how many years have passed since 1995 in 1995? So that just represents T equals 0. All right, so all we have to do here is replace T equals 0. And of course, we see that in the first two terms, they just disappear. So I'm just left with $5.36. Okay. So there's my average cost. So essentially they were asking us for the y-intercept of this function without necessarily saying so. Okay, so we got to keep in mind that this t value represents the number of years since 1995. So in 1995, no years have passed. That's why t is equal to 0. All right, so let's go to part B. So it asks when were prices at their lowest, and then in part C, what was the lowest price? So anytime you see something that has to do with highest, lowest, biggest, smallest, you know you're talking about the vertex, because that's what helps us determine the maxes and mins. So the first thing I'm going to have to do here is complete the square. All right, so this one here requires a little bit of work. So step 1 for completing the square is factor out whatever the a value is from the first two terms. So 0.06. So here we're left with t squared minus, and in order to figure out what's left when I factor something out, I just have to divide out the number. So here we have 0.27 divided by 0.06, and that's 4.5. Okay, so minus 4.5t. Okay, and then the 5.36, we'll deal with it later on. Okay, next step is to go through the process of completing the square inside this square bracket. So here t squared minus, so we need to write the middle term as 2 times something. So that's going to be 2 times, that's 2.25. Okay, because 2 times 2.25 is 4.5 t. And then I have to add and subtract the square of this number. So plus 2.25 squared and minus 2.25 squared. All right, and then plus, always make sure you write, even though we're not dealing with it right away, make sure you always write it there. Okay, and so of course, the whole reason we do all this is so that these first 3 terms give us our perfect square. So the first 3 terms here are going to be t minus 2.25 squared, and then I'm still left with the minus 2.25 squared at the end. All right, so next step is to distribute the 0.06 back in to this square bracket. So the first part, 0.06 times the first expression, the t minus 2.25 squared. And then here, I'll do this on my calculator. So we have, what do we have here? We've got 0.06 times negative 2.25 squared. Okay, and that gives us 0.30, I guess. So since we're dealing with money, I'll just leave it as 0.30. So that's minus 0.3 plus 5.36. So now we'll bring in this 5.36 to simplify. So 0.06 t minus 2.25 squared, and then here we're going to add 5.36, so 5.06. Okay, so now that we've completed the square, let's actually answer the question. Let's see what they're asking us. So here they're asking us for when the ticket prices were at their lowest. Okay, so that means we're looking for the t value of the vertex. So when the minimum occurs, and that occurs at t equals, so here the min occurs at t equals, so this number here, remember, gives us the x value of the vertex. Okay, but we want to give our answer in terms of the year. So remember that t represents years since 1995. So if we add 2 to that, so that means that this occurred in 1997. Okay, therefore 1997 had the lowest prices. All right, now we can answer C because C asks us what was the lowest price. So lowest price is the C value. In other words, the Y value, and the Y value of the vertex is given by the 5.06. Okay, so here the lowest price in 1997 was $5.06. Okay, so very important that just completing the square is not enough. You have to then use that to interpret the questions that they're actually, or the answers they're actually looking for. Okay, now let's go to D. It says show that the price was never $0. Okay, so remember, this just represents a model for the cost, and maybe the model doesn't always work. Maybe by the time you get to 2005 or 2015, maybe this model is no longer valid. So what they just want us to show is that this is never equal to 0. Okay, so I guess what we could do is do it directly. I'll actually show you a way to do it indirectly in a second, is to actually see if it can be equal to $0. Okay, so what I'm going to do is I'm going to replace C by 0, and I'm going to try to solve this equation. So let's see what we're left with here. We have 0.06. Now, by the way, notice how I'm going to use this version of the equation and not that version of the equation, because I can't solve by opposite operations using this version, but I can when it's in vertex form. Okay, so keep that in mind. So t minus 2.25 squared plus 5.06. And if I try to solve this, well, let's bring the 5.06 to the other side. Becomes negative 5.06. Okay. Okay. Next step here, I'm going to divide both sides by 0.06. Okay, so here 5.06 divided by 0.06. So that's negative 84.27. And the next step would be to take the square root of both sides. And I think this is where now we're going to see the issue. So remember, it's the positive and negative square root of negative 84.27. But lo and behold, we have a negative inside the square root. So this is impossible. Okay, you can't take the square root of a negative number. So what's our conclusion? Therefore, C can never be $0. Okay, and we've confirmed it. Now, just as a little aside here, we actually could have answered this question without doing the algebra. I wanted to show you the algebra because sometimes it needs to be done when there are x-intercepts to be found. But you could have also made an argument to say that the minimum value was 5.06, which is a positive number, and this parabola opens upwards. So if the minimum value, okay, is at 5.06 and the parabola opens upwards, then you can argue that there's no time at which this parabola is ever going to hit the x-axis. So had you made that argument and explained it very clearly, I would have accepted that too. All right, so let's just do a quick recap. First of all is to understand what the two variables represent, especially the t-value, years since 1995, okay? Then figuring out what needs to be done. In part A, we were looking for the x-intercept, or in this case here, the y-intercept, in this case here, the c-intercept, so when t was equal to 0. Okay, in part B and C, because we were interested in things that were related to the maximum minimum, we completed the square and then used that information to answer the question. And then when we wanted to determine if this function or the y values could ever be equal to 0, well, we just replaced the y value by 0 and tried to solve. In this case here, it was impossible to solve. Okay, that's it for this one.